I am so excited to have this opportunity to share with you the work of a decade. I've actually been here 13 years this year at the university, and I've had a lot of really great adventures along the way. So I want to share with you some highlights from a variety of projects and give you some takeaways that I think may help you take technology and make it work for you and your teams. So I use the word here, the messy work of making technology useful for architecture, engineering, and construction. And I'm going to unpack that word messy a bit for you, but I think you already from the keynote this morning have a sense of some of what that messiness is, right? That we work in teams, in groups, in organizations, and that starts shaping and forming the ways that we can do our work. So as I got into the research here at the university, studying emerging technologies in our industry, I found that many of the questions that I had were organizational in nature, were about how people were working together as much as about how data works together. And so I realized as an engineer, I needed to reach out to others who had skills in studying people, because engineers aren't trained to study people, right? At least I think I see some nods of engineers saying, I'm with you. Yes, that's true. So I had the great fortune to meet Dr. Gina Neff as I started my time here and have established this lab called the Communication Technology and Organizational Practices Lab, where we bring social science and engineering together to study technology in architecture, engineering, construction, and operations. Since that time, we've welcomed Dr. Laura Osborne into the lab, and she and I now are taking the torch forward in our work in this area. So a lot of the work we've been doing is looking at information technology. What are the tools we're using in the industry to manage our information and communicate with others? We also focus on collaboration. How do people work together? How do teams from different firms come together to design, make decisions, operate, build these projects? And the overall goal is, how can we make projects better? And this has a two-pronged goal. First is, how do we make the process of building and constructing projects better? And also, how do we make the resulting facility better? And that, I think the second goal is influenced by the first, right? If we can make better decisions throughout the design and construction process, we can have a better outcome. So this is our cornerstone of our philosophy and our goals for these research projects. All right, as Giovanni suggested, I am going to be sharing with you three streams of research. So this is a lot to bring into this talk, but I'm excited to share some of the highlights here, and we of course can talk about the details in all the ways that we have to interact at this conference and afterward. So first, the work around BIM and energy modeling. We've had a whole stream of research, very good fortune to be funded from the National Science Foundation to study building information modeling first and then energy modeling, and really study how these tools are being used for decision making in our industry. And we started in 2007, and that project wrapped up in 2016. In the second stream of research, we look at globally distributed teams. So we know in our world, more and more times, we're bringing together teams that are geographically not connected. In fact, I've connected with someone from San Francisco and from New York and from Germany and from Canada. Our teams are distributed. And so what we learned here in watching co-located teams, we then look to the globally distributed teams and how can they do the work that they need to do when they can't sit in the room and work together. And then finally, and kind of technically challenging, is that notion of information exchange. How do we get data from one computer system to another computer system? And we're going to be able to drop into each of these streams of research and talk about a few of the highlights in today's session. All right. Main takeaway number one from the first stream of research. And I'm going to unpack this a little bit, but hold this thought, that the organization needs to mirror the technology. The organization needs to mirror the technology. So what do we mean by that? Well, to get started with, what we found when we were watching engineering, architecture, and construction teams working was that the information didn't replace the dialogue. They weren't sending models and then it was all solved and resolved. No, in fact, sending models required more intensive interaction with each other. They needed to sit down and figure out where were the boundaries of the models they were making, how are they going to be responsible for the scope of work they're taking on, and then once the models were consolidated, how did they resolve the challenges that emerged when they saw the models together? So we saw that information exchange did not replace dialogue. I think in some of the early BIM articles and hype around BIM, it was like, oh, this will help us collaborate. Everyone will just know what's going on because they'll have the model. Well, that was not true. And I don't think will ever be true because of the ways that we work, the ways that we are people. We need to have the experts along with the data for meaningful decision-making on our projects. We also found, yeah, and I kind of mentioned this, the information technology requires teams to work more closely together. That through BIM execution planning, through sitting down and figuring out what kinds of models are being generated by whom, and then if somebody else is going to use your model, how are they going to use that? Understanding those model requirements was key to getting some of these projects to work. And so we found that working more closely together was a requirement. And I'm going to show you a couple examples of that. Before I do show you the examples, though, I want to illustrate how we know what we know, so you have some basis for our knowledge. And in the research area, we call this research methods. This is how our method of knowing what we know. So for our technology and collaboration studies, we had two streams of research. One was around BIM, building information modeling, a 4-year project from 2007 to 2011. And what we did was we started watching in the field. We did ethnography, meaning we sat and observed teams working in the industry. We had a chance to look at 5 AEC owner teams, and we also looked at 3 different projects, one of them longitudinal, watching it all the way from design through to construction. So essentially what we were the fly on the wall watching you all do your work, right? We were there able to see how the work was actually being done and being able to reflect with you and for you on what was happening around the modeling information and the challenges. We also had an opportunity to interview 125 experts in the industry from all across those roles, architecture, engineering, construction, and around the nation. So we were able to what's called triangulate our findings in the cases with this broader sense of what's happening in the industry in general. And then we were able to take those findings and essentially test the hypothesis that BIM plus collaboration equals high-performing buildings. And we found that in the AIA COAT award-winning projects, we found some really nice synergies between our findings in the cases. Teams need technology and dialogue in order to create high-performing buildings. The second stream was energy modeling, and thus picked up where our BIM work dropped off. And we had a 3-year project from 2013 to 2016. Here we see something very similar. We use the same method, right? And we did our observations. Quickly, we did 3 energy modelers. Here, it wasn't the project that was the center, it was the energy modeler and their work. We did 3 energy modelers with 18 projects. Here we had a chance to do 20 interviews nationally, and we studied 7 high-performance hospital cases. So this is why we know what we know. We had a chance to watch this work. We had a chance to see real projects coming together with experts around them. And so, although I can't share with you all of the journey that we took on those projects, that's a lot of data if you know ethnography, but I'm going to be able to give you 2 examples that help you understand what we mean when we say organizations need to mirror technology. And this is the first one. Many in the room today will know that this will seem familiar to you. It's a consolidated BIM model where we have different detailers creating shop drawings in 3 dimensions, bringing them together in a shared platform, and be able to then do 3D coordination and clash detection to understand how they're working together. Here we have the electrical sub, the fire safety subcontractor, the plumbing subcontractor, and the HVAC subcontractor. They're all there, they got their models, they see how they interact, but they interact with some other scopes who aren't in the room. Who was not in the room? The structural engineer? The architect, yeah? That's right. Yes, they're here. The scopes are in the model. That's right. The scopes are in the model, but the whole rest of the project is represented by the general contractor project engineer. And that engineer tried as hard as they could to communicate back to the broader project, but they were isolated. And what happened then was these teams retreated to their own scope. They took care of themselves and where they could influence each other, but they had no influence or ability to have a dialogue with structure and architecture. It was kind of this fixed thing that they had to work against. Whereas there were some opportunities for actually improving this project that weren't realized because that dialogue wasn't there. So I think now you're probably not surprised when you know that our third team, who joins the MEP team, but the engineer and the architect. And all of a sudden the dynamic of that team really changed. They built more trust, they had much more dialogue between design and construction, and they were able to resolve some challenges that they faced that perhaps would not have gotten resolved in the former structure of isolated MEP teams. So this is what we mean by saying that the organization needs to mirror the technology. In this MEP process, the technology has those different building scopes in it. It has the architecture scope, the structural scope, and then all the subtrade scopes all together. And the organization around that and in that meeting needs to reflect the scopes of work that are present in the model. And this is what really gave that team the power to have conversations and make the best choices for the project. And it changed the culture of the way the team worked, because now they were saying things like, well, I better move my duck because that's best for the project. They were able to come out of their own scope and be in relationship to a project-oriented philosophy and improve the design. Everyone with me? So next MEP team, who's going to try to get there? The architect and engineer in some way, right? Not everyone can do that, but hopefully in small ways and large, you can do that. So what we found then when we moved to energy modeling was the exact same phenomenon. We're following these energy modelers around, and some of them on some projects were isolated. They were sitting in their own desk trying to get this energy model to work and trying to be in conversation with mechanical engineering and the owner, but having to make a lot of assumptions that they were fairly uncomfortable with, and they weren't sure that that was the right choice. But they also weren't in conversation with the owner or the HVAC engineer in the same way that they needed to be. So here we have building enclosure, well, there's the architect there, lighting system, perhaps a lighting designer, owner-driven strategies, owner-operator, comfort delivery systems, HVAC engineer, central plant systems, and control systems, HVAC engineer, and owner-operator. So it may not surprise you now that you know what I know, the organization needs to mirror technology, is that the teams, the high-performing hospital teams, they were high-performing because they figured this out. The owner was at the table helping with the energy modeling, doing the iterations, talking through the choices, because in an energy model, you're pulling information and data and the way the building works from the owner, from the HVAC design, and from the architect. That all has to be coordinated and integrated together. And you do that with a team, because in this modern day, in modern architecture and facility design, we don't have the ability for all of those expertise to be in one head. We have distributed our expertise throughout the engineering and architecture and construction community, and we have to bring people together in teams around their technology to have those conversations to make decisions that are shared across the scopes. All right, so we've learned our first lesson. The organization needs to mirror technology. Now, how do we get there? How do we create these teams? Well, what we found in our research in both of those settings, BIM and energy modeling, is that the owner is really key and a key leader in building those teams. And often, particularly in energy modeling, where there was such a deep owner engagement around building usage, that they really have an active role to play in developing high-performing buildings. There's also a key role for owners around setting clear goals and making alignment between the individual players. And sometimes you can do that through project delivery, and other times, in fact, collaborative delivery needs to be bolstered by team building and partnership. So the owner representative role we saw to be very key in terms of the clarity of communication around goals and the clarity of the alignment of those goals. Because in some projects, we saw kind of the classic fracture where the contractor said, well, I heard the owner talk about design. I think design is the driver. And the architect saying, no, no, performance is the driver. They really care about this aspect of the building. And another party was saying, but I heard net zero. I heard net zero. And so everyone's kind of confused as to what's the priority going on here and having debates amongst themselves. So when you come to a project, if the owner can be really clear about the goals, then everyone can align with those goals and get them done, yeah? I think this is said often in lean and BIM and energy, getting the right people together with the right information. That's our main message from this first part. And we also found that the owner has the role of navigating between boundaries. Owner is in position to kind of know who knows what, and so they can kind of make introductions and also know that perhaps either through payment schedules or through team building exercises, know that they want you to have those conversations and not to be siloed into your discipline, right? So owner has a role of setting up the team and also navigating those boundaries between the individuals. All right, so now we've built our team. We have a good team on our hands. How do we set them up for success? How do we set them up for interacting with each other successfully with their technology? This is where the messy part, the messy work came in. As we were sitting there talking about our BIM teams, we saw their work looks like this. It looks like a team when there's lots of paper around, everyone has a pen or a pencil in their hand, sometimes tracing paper is thrown over the whole thing and more stuff happens, and there's computers involved being thrown around, well, maybe not literally, but there's a really kind of active, informal, flexible environment where these teams are interacting. Whereas when we looked at BIM, BIM was projected onto the wall and it looked beautiful up there, but it was more passive, perhaps even more formal, and it seemed a bit inflexible. And so we saw this conflict between, we characterize it as the clean technology and the messy work that needed to happen. Messy being really about sketching on top of things and the informality of idea generation, so that you're not documenting anything when you're doing this, and then you figure it out and you document it, perhaps take a picture of it and send it out. So there was this scale between the active work of idea creation and then formalization and dissemination of the decision. So from that, you might be able to conclude with me that my favorite projection system of all time right now, to create a place where you can project your computer onto a whiteboard and you can draw on it, right? That's the merger of those two ideas. You have this messy thing that you need to do, you need to draw ideas, so maybe project your stuff up there and draw on top of it would be one way to solve that problem of how to get your clean technology into a messy and interactive environment. Now this idea of interpretive flexibility, so we said, okay, that's a physical flexibility, but we also need a mental flexibility, ability to imagine new ideas inside our designs. And architects know this, whether they know it explicitly or just know it inherently in terms of their training, that when you see something that's kind of as finished as that, it feels kind of done, and it doesn't give you as much space to kind of think about new ideas, or what if we did that? So when we looked at the literature around architectural design practices, there was a statement about, well, we keep things intentionally abstract, right? That they work over here in a more abstract environment where we have a floor plan, and the structural engineer, the mechanical engineer, the architect can come in and everybody sees their own work in that floor plan, but it's not explicitly there kind of getting in their way for ideas. So we see a lot of sketching happening on those floor plans, and that's where the ideation work is happening. Other kinds of modeling technology isn't replacing our traditional practices, isn't replacing hand sketching, although a lot of sketching is done on computers these days. It's not replacing two-dimensional representation. In fact, we found two-dimensional representation is still a very much needed representation for communication. One of my favorites has been that a superintendent, he printed a floor plan of the building on a whiteboard, and then was able, every day, that team was drawing on top of that floor plan, right? That was my great, there's a messy talk whiteboard going there. So it was the floor plan that was needed because they needed to fill in the details of the concrete pour schedule, of the delivery schedule, right? There's all kinds of information that got filled into that floor plan. So as you set up your teams for interaction, think about this, that if you really want them to study and understand and discover things, the high level of detail is a good place to be. If you want people to come up with new ideas and create, brainstorm decisions together, an abstract place is where you want to be. So you want to be able to, and often in our teams, we actually saw them toggling between two things. They'd look at the BIM, they'd discover an issue, they'd move to the whiteboard, draw out a floor plan, and start working out the issue, right? So you kind of need to toggle between these two things. In fact, I think that's my next slide. So you want to intentionally curate spaces that support the visual practices of the teams. And they need to toggle between these two things. They need to toggle between a discovery and understanding place where they need the highly detailed. That's what BIM does really well. It helps just create a shared understanding across the team of what the heck you're talking about. That beam is going into that duct, or that duct is going in the beam, depending on whose trade you're on, and you got to solve that, right? Everybody gets that then when they see it in the model, but then how do you solve it? You typically aren't seeing people push the beam around or the duct around in the model. No, they're going to paper and like drawing out some ideas for that. So that's where we see the messy talk needing flexible, malleable media and abstract representations. And so as we introduce more technologies, AR, VR have been discussed today in some parts, we need to think about these needs for visualization and needs for interaction with our media that our teams need for these kind of ideation and discovery. We have these really interactive, very rich environments that our co-located teams were using. What happens when we distribute them and we put them around the globe? Now we don't have that opportunity directly to sit down with each other on a whiteboard or sit down with each other on a paper and pen. We're distributed, we're stuck on email, we're stuck on maybe virtual worlds if we're getting really fancy, yeah? And so how can we set up global teams for success in this area? So we had another study that was looking at virtual worlds and kind of looking at what we called the affordances, meaning the features of that world and how we could use that for the successful collaboration. So let me introduce you a little bit to the world we were using, because this is kind of a key part of this story. So this world is known as the cyber grid. It was developed by my colleague, John Taylor. So he took the lead on developing this space. It's based in a Unity platform, for those of you who want to geek out with me. And so we had this environment where users would enter as an avatar. This is a computer object that represents a single user in the space. So there's other people in the space with you that look like little computer humans, yeah, and they're walking around with you. So that's what's happening here, and you can see the names of the other students in this building walking up the stairs and taking a look. So this was a first-person view of being able to walk in and take a look. So each user had their own kind of ability to walk through it. So it's really a virtual walkthrough, as if you're walking with your buddies through a building and pointing out issues, right? So this was characterized as independent views and was very much a fixed model in this situation. Then when we had collaboration spaces, you can see the model out the window there. In here, they were able to do a shared screen view, like GoToMeeting, WebEx, Zoom, there's a number of them available now. That was like that, sharing the screen. And we see also here the ability to draw on that screen. So you see the pens there. These avatar humans are actually drawing on that screen. And there's a little mini model there too. So this had a shared view. So they weren't having independent views as they did here, but all looking at the same shared screen. And this was a mutable object. They could draw on top of it. So what do you think happened? The same thing that happened in my BIM teams. I was so amazed, not amazed, but excited, because there was the dialogue, there was the discovery. So just like in BIM, they went to the BIM to discover things, and they went to the paper to draw it out, to dialogue around it. And here in this virtual world, they were discovering things in this model, and then they come in here to talk it out. And the evolution of that dialogue was really fascinating too, because they started with trying to manipulate the model itself. Can we move this wall? What happens when we did this? And it was too slow to do that. The model wouldn't be edited fast enough, or they weren't fluent enough. And so they ended up just showing an abstraction, right? We just talked about that. Showing an abstraction, here is that plan, and drawing on top of it, just like my teams out there in the BIM world who were co-located. So here we gave the students an ability to manipulate the data in a similar way to the co-located students, and they were able to have that dialogue and share ideas together and explain those ideas through sketching. So very key. Now, there's a question about, as we move into VR generally, we've done a number of studies in our lab around VR, and we've tried kind of different types of interfaces. And one type of interface is that kind of the one we were just looking at. It's on a shared screen or a flat screen, and you're seeing a 3D world, but you're seeing it through a flat screen. And then there's immersive display systems. This one's the lightweight system by Visual Vocal, and then there's other systems with the full headset systems, right? We have this whole range of VR tools at our disposal. So what we see in this space, and this is confirmed both in the study I was just speaking about, our distributed team study, as well as Lucky Pratma's master's thesis that was featured in the poster session, those both say these same things, that when users were immersed in the world, they tended to be in first-person view. So they would go to the middle of the job site and take a look around in first-person view. When they were in the shared screen mode, so when everyone was seeing the same view, they tended to stay on the outside of the building and look at the third-person view, see the project from the outside. So this has ramifications for what you see as a team, right? If you're kind of on the outside of the building, you're seeing those things, and if you're on the inside first-person view, you're seeing other things. And it's not that shared screens don't go inside and immersive screens don't go outside. It's just when people go into these spaces, it tends to be where they want to go. It's the instinct to stay out or go in. So when we looked at teams, we had 3 teams in the cybergrid space, and we had 3 teams in the shared screen space using something like GoToMeeting. What we saw was a pretty striking difference between those 2 teams and what they were able to discover in the model. And we didn't tell them how to navigate their model together. We basically were an open-ended experiment where they went in and we just watched them work and see what they would do. So these teams who stayed outside their model and looked at it through a shared display, they found about 10 issues in total around the model shared on the screen. Whereas in the cybergrid, when they were those avatars and they went inside the building, they saw significantly more issues in that building. Where do you want your MEP teams to be? You want to have them finding as much stuff as possible in the model before you get to the job site. So I think this is helpful to think about how to set up teams for success in terms of the hardware you're giving them and what kinds of interaction that you want to encourage. If you're in a shared screen system, be sure to encourage them to go inside and walk around, which many MEP teams do now out of practice, right? They know to walk through the building and take a look. Whereas if you're in an immersive space, know that you probably want to step back from the first-person view and take a look at that, because there might be some things you want to see from the third-person view also. So you need to toggle between first-person and third-person view when you're in these models and in various different display systems. Big breath. We're on to the third topic. There are a lot of challenges, as we heard this morning, around exchanging information and data from one system to another system. Right? Even internally, in an internal BIM department, that's challenging to exchange model data from one software to another software. Or if you're going from a BIM environment to a VR environment. All of these exchanges are really challenging. In our lab here, we've had a chance to work with several owners, several large institutional public owners, around these questions and start tackling this challenge. The first project was with our own University of Washington Capital Planning and Development Group and the Facility Services groups there to look at what's called Construction to Operations Building Information Exchange, known as COBE. In BIM for FM, COBE is kind of now a universal term for thinking about moving information and data from construction into operations. And we explored that for a long time, and one might argue we're still exploring that and trying to get those kinds of information to work and build standards around that. We've also had a chance to work with Sound Transit on asset data deliverables and BIM requirements. And we also worked with the Army Corps of Engineers on a BIM to Builder project, Builder being a life cycle finance management tool that the US Army is using. So I am not going to be able to unpack all of those projects. They are incredibly complex, just as our morning keynote was complex around LAX. But what I can say that the universal experience of all of these is that when you first try to take a data set, and in this case we're talking about a BIM data set, and try to hand it over to someone else, there's a breakdown. It doesn't go. It doesn't go very easily, if at all, when you initially try to do that. And so when you have that breakdown, you have to have experts who like to play with data, start looking at data structures and trying to figure out, is there a way we can automate the exchange between one data structure and the next? And in our BIM to Builder project, we identified these processes where we had to extract the data out of the model, and then think about data integration. How do we bring the data together that we want to put in it? And mapping it, and then data validation. So we want to make sure that the data was right before we send it off to the next user, yeah? So information exchange, I think sometimes people think about it conceptually really simply, that you're just taking this data over here and passing it over there, like you're taking marbles from one bucket and pouring it into the other bucket. But there's actually all this process that needs to happen on the way, where you have to think about each of these steps and do it in a smart way. Otherwise, nobody trusts the data or nobody knows where to put it when you give it to them. So let's talk a little bit about structure, because the breakdown and repair process is that you realize often that the structures don't speak well to each other. And in this example, we have a Revit file coming in from the BIM side and Builder receiving that file. And Revit organized things here in category, family, and type, but Builder wanted things in building, system, component, section, subsection. So I think everyone can see that it's going to be really hard to go from type to subcomponent. Yeah, it doesn't map very well. So we did a lot of work and have come up with some ideas about how to do that. There's a lot of work happening in standards and classification systems to try to get us there. But as my colleague John Messer said this morning, that there's still a proliferation of standards that make it challenging to get this work done. Even in this context, although they were both working in Uniformat, they were working in two different versions of Uniformat, and the Builder Uniformat had this special subcomponent that was a customized category from the Army. And so while we were trying to be in Uniformat, it still didn't actually speak to each other very well. And I think I'm going to end on this message that it takes work to get our models and data to work for us. It takes investment. And it takes kind of an acknowledgement of that. It reminds me of the Dilbert cartoons, like the boss saying, well, I don't know about that, so just to take 2 minutes, right? And where it's a 3-week project. So it takes work to get these to work. Not only setting up the right team around the data, setting up the right space and interaction, hardware, software, paper, pencils. And it also takes work to understand the structures of our data sets and our software to get them to work together. So something I hope that you take away from this talk is that models and data are not absolute. It's not just a bucket of marbles, but they have a history, they have a structure, and it takes work to understand that construction and then be able to create a roadway between that structure and another one that you need to exchange with. And I would applaud, I do applaud all of my technical participants in my projects and the work that you're doing out there in the industry, because this takes reflection, it takes creativity, it takes patience, it takes experience and experimentation, and it takes investment to get this to work. So I applaud all of the BIM and energy modeling and globally distributed teams and information exchange practitioners out there, and keep doing the work that you're doing. And I hope you've enjoyed some of the lessons I've had to share today.